Dear students, today I want to revise the topic circular motion, maybe the very important one for JEE, NEET and KEAM aspirants. At first, we can move through the different terminology. See, the circular motion means the motion of a particle along the circumference of a circle, maybe in a horizontal plane or a vertical plane, but it's the best example for two-dimensional motion. The first very important term, the angular displacement, the angle subtended with respect to its center. For small magnitudes, that angular displacement is taken as a vector quantity. We can say one of the axial vector. But for higher magnitudes, it is treated as a perfect scalar and is expressed in terms of radian and has no dimension, and is a good example for a physical quantity having unit but no dimension. We can relate the angular displacement with the linear displacement through the relation angle is equal to arc by radius. Here it is denoted as S is equal to r theta. In vector form, and here the displacement, the radius vector, the angular displacement are vectors, and hence we can represent them in as the example for vector product as S take the value is equal to theta cross r. And keep in mind, if a body makes n revolutions, the total angular displacement takes the value 2 pi n. While studying this concept, you should compare it with our linear motion. So in place of displacement, you can take the term as angular displacement, and in place of velocity, you have the term here, the angular velocity omega. We have to give importance to two terms, the average angular velocity and instantaneous angular velocity. The average means for a particular time interval, what is the change in angular displacement. But instantaneous means at a particular instant, we can say as d theta by dt. And keep in mind, it is a vector quantity and is expressed in terms of radian per second with a dimension of t raised to minus 1. If the particle undergoes one complete revolution, there is a time that is called the time period, then the angular velocity takes the value 2 pi, that is angle for one complete revolution by the time period t, or it can be equal to 2 pi into the frequency. We can relate the linear velocity with the angular velocity through the relation v is equal to r omega. By using the right hand thumb rule, we can assure about one thing, it's a cross product v is omega cross r and not r cross omega. V is equal to omega cross r. The next term, there is angular acceleration. So in place of linear acceleration, in a circularly moving body, we can interpret the term the angular acceleration. The average angular acceleration, omega 2 minus omega 1 by t2 minus t1. The instantaneous, the first differential of omega or the second differential of angular displacement, and is expressed in terms of radian per second square with the dimension t raised to minus 2 and is a pure axial vector. We can relate between the linear acceleration or the tangential acceleration with respect to the angular acceleration through the relation as at take the value equal to r alpha. In vector form, as at is nothing but equal to alpha cross r. You can wait for the problems that relation with the kinematic relations You can compare the relation for a body angularly accelerated, then there are some relations. In place of v is equal to u plus at, here the term, the final angular velocity is equal to omega 0 plus alpha t. In place of v square equal to u square plus 2a is the omega t square equal to omega square plus 2 alpha theta. The angular displacement at any time t equal to omega 0 t plus half alpha t square. The angular displacement in the nth second is equal to omega 0 plus alpha by 2 into 2n minus 1. And we can express the angular displacement is equal to the average angular velocity into time. That is omega t plus omega 0 by 2 into t. But keep in mind, the body must move with the constant angular acceleration. We move on to the very important our topic, uniform circular motion. You can just think about the tip of the second hand, the minute hand or the hour hands of our clock. A best example for uniform circular motion. And keep in mind, the body covers equal angular displacements in equal interval of time. And keep in mind the parameters, the linear speed, not the linear velocity. The linear speed is constant. The angular speed is a constant. Therefore, the further quantities, the tangential acceleration and angular acceleration should equal to 0. Then we can say the velocity, its direction, it is continuously changing. And that change in velocity should contribute an acceleration. And that change in velocity is acting along the radius towards the center. And that contribution towards acceleration is called the center seeking acceleration, the centripetal acceleration, or radial acceleration. So keep in mind the very important concept. The centripetal acceleration is contributed by the change in velocity direction. And got the equation as v square by r or equal to r omega or equal to v omega. If a particle is moves with the constant speed, we can use the relation as v square by r. Then in vector form we can written as the centripetal acceleration is equal to omega cross v. From this figure we can think about the direction of different parameters. The linear parameters all are acting linearly, tangentially, but the angular variables, they are acting along the axis of rotation. AC, the centripetal acceleration along the radius towards the center. So we are sure about one thing. For a body under uniform circular motion, we can say its linear speed is constant, the angular velocity is constant, but alpha and at is equal to 0. But what are the conditions for a non-uniform circular motion? And there the linear speed is not constant. That is a relevant situation. That means its speed goes on increasing or decreasing. That means omega is not constant. At and alpha is not equal to 0. So for a body under non-uniform circular motion that is suffered with 3 accelerations at a time. 1, the centripetal acceleration, and keep in mind the contributor is nothing but the change in velocity direction and is acting along the radius towards the center. The second one, the tangential acceleration. Keep in mind it is because of the change in speed and is acting tangential to any point. And the third one, that is angular acceleration, acting along the axis of circular motion. So we are with a very important point, and keep in mind, in the real concept, in the plane of circular motion, the body is suffered with two accelerations at a time. AC, the centripetal, AT, the tangential. AC because of the change in velocity direction, but AT because of the change in speed. So these are the very important factors in relevance to our non-uniform circular motion. We can move with some important problems. Here, the angular displacement of a body is given by theta takes the value 2t cube plus 5t square minus 3. The value of angular velocity at t is equal to 1 second is. So we know how to find the angular velocity. It is nothing but equal to the first differential of angular displacement. So you get the value as a 6t square plus 10t. If you put the value t equal to 1, we get the answer. A particle moves in a circle of radius 2 cm at a speed given by v is equal to 40, where v is in centimeter per second and t is in second. We have to find what is the tangential acceleration and what is the total acceleration at t is equal to 1 second. You must thoroughly know the concept behind this relation. We already said one point, the tangential acceleration, that is because of the change in speed. And there it is dv by dt. So you just differentiate one time. You get the value as a 4. But what is the centripetal? The v square by r. We already v is 40. You can substitute t is equal to 1. And we get the value as 8 centimeter per second square. But in the plane of circular motion, this AT and AC makes an angle of 90 degree, and hence the net value takes the value root of AT square plus AC square, that is equal to 4 root to 5 centimeter per second square. A good concept. While solving problems, you must think the concepts with the linear motion. That type question is here. A wheel is subjected to uniform angular acceleration about its axis. Initially, its angular velocity is 0. In the first 2 seconds, it rotates through an angle theta 1. In the next 2 seconds, it through an additional angle theta 2. Then the ratio theta 2 by theta 1 is. And here it is given, it starts from 0, rest, and hence the first angular displacement can be written as theta 1 is equal to half alpha, it's a time as 2, so 2 square. In the second case, the situation becomes so easy if you just start from initial point. So you have to take the total displacement theta 1 plus theta 2 is equal to, so initial velocity is 0 here, so half alpha 2 plus 2 the whole square. So you can just divide and you get the value as 1 by 4, you get the answer. The similar concept is with our one-dimensional motion chapter, keep in mind. Then we move on to some higher order concepts, the centripetal force, and keep in mind the responsible force for a circular motion. In a uniform circular motion, keep in mind there is only one force acting on it, and that is the centripetal force. And we can just go through some examples. In a stone string system, and keep in mind the tension is the responsible one. In a earth-moon system, it is the gravitational force of attraction. For a nucleus electron system, it is electrostatic force. For a vehicle on road, the friction. With a relevant concept to keep in mind, the force, the centripetal force is equal to mass into acceleration, m into v square by r, or r omega square. A very important equation. The centrifugal force, the pseudo force for a non-inertial frame. So here, in place of centripetal, and here the term is centrifugal, and got the same magnitude as that of the centripetal force, but opposite direction. And keep in mind, there is a reason why, while moving in a vehicle, we are thrown outside, and got a lot of applications. Look, the principle of the dryer section of our washing machine, honey extractor, centrifuge are the best example for centrifugal force. Look at the very good question. A particle is placed at the highest point of a frictionless hemispherical surface. If the surface is allowed to slide down, the angular displacement theta at which it will leave the surface. So, initially the body here, give a small jerk, it will come down. By losing its potential energy, it is converted into kinetic. So at any point, we can write the equation of motion. Here, the centripetal force m into v square by r, that is given by the component of weight as mg cos theta. So m into v square by r equal to mg cos theta, but it is loosened by the reaction, the normal force. So minus r. But here it will leave the surface, means the reaction becomes 0, and hence we can written as m into v square by r equal to mg cos theta. We know it loses its potential energy, and hence half mv square take the value as mgh. So to substitute for mv square, we can take the value as 2 mgh. And if we just take the value of cos theta, the adjacent side r minus h by r, you can solve to the value cos theta equal to 1 by 3. A good concept, keep in mind. A lot of applications with circular motion, and here the motion of a car on a circular level rod, and keep in mind there the centripetal force is given by the frictional force. That vehicle will cover the circular motion only and only if the centripetal force there should be less or equal to the frictional force. You know the value of friction there as mu mg, and hence we can easily find what is the maximum speed with which that vehicle moves, that is root mu rg. The next one, the bending of cyclist. If the friction is neglected, in order to move with maximum speed, that cyclist or bike rider lean from the vertical. For what purpose he leans? And here the weight, here the reaction, that can be split into two components. And for this circular motion, the horizontal component of reaction is acting along the radius towards the center, and that will provide the necessary centripetal force. By using the equation of motion, we get the very important relation in how much angle that the cyclist should tilt to move with a velocity v in a circular path of having radius r. So you get the relation tan theta equal to v square by rg. Look at the very important concept for a banked curved rod. If friction is neglected or it is not sufficient to give the centripetal force, and there also the reaction component r sin theta will provide. And from that also we get the relation. But keep in mind the angle is equal to tan theta is equal to opposite by adjacent. So H by L. So maybe the very important equation and is employed by the railway engineers, and how much the outer rail should be raised with respect to the inner rail for the movement of a train with a velocity v. The next one, if you account mu also, the friction is acting between the vehicle and the road, between the tire and the road, that F can be split into two components, F cos theta and F sin theta. So the two components will give the necessary centripetal force R sin theta plus F cos theta. But vertically, if you consider, the R cos theta is balanced with F sin theta plus mg. And then we solving, you get the very important relation as v square by rg take the value equal to tan theta plus mu by 1 minus mu tan theta. And keep in mind, if mu becomes 0, you get the relation as a tan theta equal to v square by rg. Look at the very important concept, the motion of vehicles on different bridges. Here the plane bridge, the concave upward bridge, the convex bridge. The situation here is the vehicle is at the middle of these bridges. The plane bridge, or with two forces, we can say the mg is balanced with r1. But the concave bridge, it is a part of a circular motion. There the reaction is acting along the radius towards the center. We can assign that will provide the centripetal force, and hence we can written as m into v square by r is provided by r2, but it is loosened because of the weight, and hence we subtract it, and hence we can find what is the reaction acting on it. Similarly, on the convex upward bridge, the component along the radius towards the center is the weight, and hence the centripetal force is given by weight, but it is reduced by the factor of r3, and from that we can find the reaction on each vehicle. And if we just compare the reactions on the three cases, it is too difficult to move in a concave upward bridge. A very good question, an outstanding question. A railway truck has its center of gravity at a height of 1.2 meter above the ground, and the rails are 1.5 apart. Calculate the maximum safe speed with which it would travel around the unbanked curve of radius 32 meter. A very special equation for you. The velocity is given as root of grb by 2h, and keep in mind b, that is the width of the rails, and h is the location of the center of gravity with respect to the ground. So that is a very important concept. Conical pendulum, it's a very good example, another circular motion. And keep in mind another one as a death well. So very important one. So that cylinder is under circular motion, then the object which is stuck to the surface is under circular motion. So here the forces are, the weight is acting vertically downward, the friction is acting upward. So here the normal reaction, that is acting along the radius towards the center, and if that cylinder is with a rotation omega, we can say the centripetal force is provided by n, and hence we can say mr omega square is equal to n. But another relation, the F is balanced with mg, then only the body can stick there. But we can written as that the frictional force is nothing but equal to mu times of reaction, and here the reaction is not weight but mr omega square. From that you get the value. It is very important concept. Based on the examination point of view, the very important one, it is a vertical circular motion. So you just take a bob, tied it to a string, and is given an initial velocity u at the bottom. If it is with a sufficient energy, it will execute the vertical circular motion. At a particular instant, say the body got theta angular displacement with respect to the vertical, then because of the height increment, its kinetic energy goes on decreasing, and it attains the potential energy. At a particular instant, say here, the weight mg can be split into two components. So for this vertical circular motion, we can write the relation for the centripetal force m r omega square, or m into v square by r. It is provided by the tension and is degraded by mg cos theta, and hence the tension at any angle we can written as T is equal to mg cos theta plus m into v square by r. In terms of initial velocity given at the lowest point, we can express it in another form as m by r into u square plus gr minus 3gh. We can find the velocity at different height by using this relation. If you think about a minimum circular motion, means we are giving a minimum velocity at the lowest point, then the particle is under circular motion. For looping the loop, how much minimum velocity is needed? While solving, we get the minimum velocity at the lowest point is root 5 gr. If we give that much velocity, the velocity at this m point is root 3 rg, and at the highest point is root gr. For minimum circular motion, we assumed as the tension at the highest point is nearly zero. During that time, the tension got the maximum value at the lowest point. The value is 6 mg. And keep in mind that the string have the chance to break at this point. The tension at the middle point become 3 mg. It's a very important data, keep in mind. A very important point, whatever may be the situation, the difference between the tension at the maximum and the minimum value is always 6 mg. The tension at the lowest point minus the tension at the highest point as 6 mg. A good example, in a previous year NEET exam question: a stone tied to a string of length L is whirled in a vertical circle with the other end of the string at the center. At a certain instant, the stone is at the lowest position and has a speed u. The magnitude of the change in velocity as it reaches a position where the string is horizontal. So in the circular motion, it reaches the horizontal position. A simple concept. But the string is horizontal, you know the velocity can be written as root u square minus 2gh, h become here L. The angle between the initial velocity and horizontal velocity takes the value of pi by 2. You can just take the equation, you get the value. A very important another question. A body slides down a frictionless track which ends in a circular loop of diameter d. Then the maximum height h of the body in terms of capital D, so that it may just complete the loop. For looping the loop, a body must attain a velocity nothing but root 5 gr at this point. So the mgh should be equal to half m into the velocity here, it should be root 5 gr. In terms of diameter, we can written as d by 2, and you get the answer. So a very important concepts, especially in mechanics. It's a base topic. You must do maximum MCQs. Then you can crack so easily the NEET and JEE main. God bless you. Thank you.